Okay, this is the beginning of Unit 2 for Honors Math Analysis. We're doing exponential and logarithmic functions. You had this topic taught to you in Algebra 2. We'll just go a little bit further in depth and some more advanced problems. So an exponential function means that the exponent is a variable. The base is this a. And we talk about in Algebra 2 growth versus decay, and we're going to talk about it as far as application problems here. When a is greater than 1, the function increases. So if I had y equals 2 to the x power, the function just continues to grow. It's a decay if the a value is less than 1. It has to be positive because then we're talking about reflections. So it would be something like y equals 1/2 to the x power, and a decay looks like this. You see growth and decay modeled a lot in science classes. Every exponential function, the domain is all real numbers, no exceptions. It's the range that is dependent upon the horizontal asymptote. So if I had a function that looks like this, my range is going to be y is greater than whatever this horizontal asymptote is. If I had my horizontal asymptote there and everything below, then my range is going to be y is less than whatever my horizontal asymptote is. Every exponential function has one horizontal asymptote, no vertical asymptotes. It's not like a rational function. For the parent function, it is always y equals 0. And then if there is a vertical translation, that is how the horizontal asymptote changes. So the vertical translation also moves the horizontal asymptote. If it just moves vertically, doesn't change it. If it's just a reflection, doesn't change it. So like I said before, everybody does really well on this idea of translations. And here we're only going to do translations and reflections. So we're going to move right or left this value of c, and that's when the number is with the variable x. Or we're going to move up and down the variable c. We can do x-axis reflections when a negative is in front. That means changes the y value. If the negative changes the x value, then it's a y-axis reflection. I'm not going to deal with stretches and shrinks. We just don't have those that often on this course. The applications that I like to talk about in this course is about compound interest. And there's formulas, and you would not have to memorize these formulas, but they're very useful. And if you do them enough, you do actually remember them. So this formula has A, P, R, N, another N, and T. And these all mean something. The account balance is how much you start with, or how much you end with, I'm sorry. The account balance is how much you end with. The P, the principal, is how much you begin with. You have your interest rate, how much time you're talking about, and then N represents the number of times interest is compounded in a year. And that's all these examples here. So I'll give you examples on the live lesson before we do these, but this is all a matter of, here's the formula. You just have to understand how to plug everything into the formula. Another problem that we regularly do in here is about radioactive decay. And so this is the formula that you would use. The book mentions it one time and then doesn't mention it again, so students struggle with finding this formula when they need it. So that's why I have it typed on the notes. Whatever you end with is going to equal to the initial amount, whatever you start with, multiplied by the base is 1/2, and the exponent is t over the half-life, whatever isotope we're talking about. So it is very much like the formula up here, except for this 1 plus r over n ends up being 1/2. And I did forget to mention, this is the other formula for compound interest, and this is used when interest is compounding continuously. And you will use the value of E, which is a constant. It's around 2.7, and I'll show you where that comes from in your calculator.